Okay, YouTube, in this last video in which we talk about functions, we're going to look at how we could use maybe a function to define relationships between a couple of real life quantities. And so let's go ahead and start by considering this example and talk about some of the things we've explored in order to help us figure out what we want to find here. So we say that a batter hits a baseball at a point 3 feet above the ground at a velocity of 100 feet per second at an angle of 45 degrees. And what we're given here is it says that the path of the baseball is given by this function here, f of x equals this expression in x here, where what we're told is that f of x is the height of the baseball in feet, okay, and x is the horizontal distance from home plate. So what we want to discover really is this, will this baseball clear a 10-foot fence located 300 feet from home plate? So a couple things that I want to make sure we do here. Whenever you're given a function to represent real life quantities, it's always good to write down what these variables are representing. And so we would say this is the f of x or y value here is the height of ball off of the ground. Okay, and with respect to x, we would say this is the distance from home plate where they hit it. So to really look at what this situation might look like, let's go ahead and draw in our x and y axes here. We could say this is our horizontal distance from home plate, okay? And also we could see that our f of x here, f of x, is the height of the ball. So we want to make sure that we can kind of understand what's happening here. So what's happening is this. Of course, if you remember from algebra, this is a downward facing parabola, and if you don't, it's okay. We can go put this into a graphing calculator anyways. But the idea here is this. We've got a batter sitting at home plate, which is at 0 or at the origin here. And what's happening is they've knocked a ball right here. And so this parabola described by this formula here, what I want to know is this ball going to be able to clear a fence that is 300 feet away? So when we're referring to this 300 feet, what we're saying is that there's 300 feet that spans here, or maybe it spans even further out to here. But in either case, we're trying to determine if this fence that is 300 feet out here will allow our ball to clear the fence. So I do not know whether or not it'll clear the fence, but I do know that this is a 10-foot fence, so 10-foot fence. So part of this is kind of describing this visually here. So let's take a look at this. Graphically speaking, what I'm going to do is I'm actually going to turn on my graphing calculator, and we're actually not going to put this into Desmos, but instead we're going to work this out with this graphing calculator. So for the first time, for some of you, maybe not for others, what we're going to do is we're going to go into graphing modes. And so whenever you want to use your graphing keys, we'll always use these top 5 keys that you see on your calculator here. So to kind of get with this example here, let's go ahead and get started. This top left button will go to y equals. And as you click on y equals here, it's going to give you a bunch of prompts for you to type in your functions, and it even gives you areas to type in multiple functions. So let's type in this expression here, negative 0.0032 x squared plus x plus 3, keeping in mind that your negative key has to be used, this key down here. Notice that that key and the subtraction key, look how they're a little bit different. Subtract is long and it's a little bit lower to the ground than negative, which is a raised negative sign. So we have negative 0.0032. Now our x key is going to be this key here where it says x comma t comma theta comma n. We're going to hit that, and then I'm going to hit the squared button here. Plus now our x key again, plus 3. So now if I want to graph this, what I can do is I can just go ahead and hit this graph button right here. And what you're going to see is the path of this baseball. Now the weird thing here is this, because we're talking about a fence that is 300 feet away here on our x-axis, what this means for us is that our x distance, we're going to have to start at an x value of 0 and go out at least 300 feet on the x-axis here. And in terms of the height of the baseball, well, I don't know how high up in the air it's going to get, but it might be good to go pretty high up in the air. So maybe I'll go like 400 feet here. So before we graph this, what we should do is we should go to window, and what we're going to look for is we're going to look for an x min and an x max command, x max. We're also going to look for a y min and a y max command here under the window setting. So the way this works is for your x min and max, I'm going to go ahead and start my x min at 0 at the origin, and I'm going to go all the way out to, since I'm concerned with 300 feet, let's go past it. Let's go out to, say, let's go 400 feet. Now when they ask me about scale here, they're saying, what do you want your notch marks to represent? You want to go by ones or tens or what? And since I'm going out to 400, maybe I'll go by 50s on my x-axis here, on my x scale. So now for our y minimum, our lowest point on the y-axis, we have 0. I'll hit enter and we're going up to 400 was my choice. So I'll go 400 here, and I'll also go by 50s on this axis. So my last note I want to mention here is that this XRes key, you shouldn't have to touch that at all. What I'll have you do now is go back to graph, and what we should get is a clearer picture of this ball. So now that I see this entire path, I notice that we went up to 400 feet, and that's not anywhere near 400 feet. Maybe it goes up to a maximum of about 100. What I'll go back to and do is change my window so that it goes up to maybe just say 200 feet. We'll get a better idea. So here's this graph here. And the question was, would it clear a 10-foot fence that is 300 feet away? So in order to determine this, what I'm going to do is I'm going to hit my trace key, and what you're going to see show up if I hit left and right now is that it traces along your curve. And so I can actually see how far away from home plate it is and how high above the ground it is at that moment. So the neat thing here is we're going to go out to 300 feet and we're going to try to get as close as we can to this and say, look, would it clear a 10-foot fence? And because at 302 feet, it's still even 13 feet in the air, we should be able to conclude that it will clear this fence here. So one thing I want to do before we type that out or write that down is this. When you hit trace, go ahead and hit trace again and actually type in 300. You can type in a specific x value and hit enter, and it will tell you precisely how many feet off the ground it is. And so we could say that on the graph here, we knew that at 300 feet, okay, it was 15 feet off the ground. We're going to type a little note here that the ball should clear the fence because at 300 feet away from home plate, the ball is higher than 10 feet in the air. Semicolon, why not? It is at 15 feet. So that being said, what I want to do is I want to look at how could we have done this also, but not graphically. And the easy way to do this simply would be that they gave us a couple of quantities down here. They said, hey, will it be 10 feet off the ground when it's 300 feet from home plate? So what we're really looking at here is this. When we plug in 300, the question is, what's going to be the height off the ground? And the way we could do this is just go ahead and plug it into our function. So f of x is equal to negative 0.0032 x, oh, that's just ugly, you guys, x squared plus x plus 3. What we're going to see now is that when we plug in 300, we should be able to get an output value. So negative 0.0032, 300 squared plus 300 plus 3. What we're going to do is we're just going to use our graphing utility to type this in. So to get back out to your main page here, what you're going to do is you're going to go to right behind mode, it says quit. And when you quit here, you're back out of your main page. We could just type this expression in. We could say negative 0.0032, and using parentheses, we could actually just go ahead and put these in here. Your calculator is quite good with order of operations. So 300 squared plus, now in parentheses, 300 plus 3. And what we end up with is this output value of 15. So what we get is f of 300 is equal to 15, but this just supports our conclusion here. We could even put this in a table x, f of x. We say 300, 15. Essentially, we can support this conclusion right here both graphically and algebraically, numerically. Cheers.